So now that we've had CNI, the Calico CNI, take the pod, build a virtual Ethernet between the pod's network namespace and the underlying host, and assign it an IP address. Now let's talk about the next stage and how Calico is actually going to make the networking work for that pod. So again, we're going to start off with the host over here. Make it a little smaller this time. Oh, I can't draw squares. That's fine. I'm not an artist. I'm an engineer. All right. So I then have, again, this boundary layer that we talked about before between the host kernel and the workload. I have my pod up here. And I'm going to put another pod up here too. That's going to explain this a little better when we get going. And I'm going to say this is pod address A1, and this one is pod address A2. And I'm going to have down here in the kernel, I'll stay with the green, I'm going to have the networking engine down here, standard kernel networking, and I'm going to represent that routing table now just as literally a table. So I'm going to have a routing table entry, and that routing table entry is going to have addresses and what's called next hops. And what that routing table is basically going to say, if something is destined to a given address, where should the kernel routing engine, the kernel networking engine in Linux or Windows, send that traffic? So that's what that table is. So this is the routing table here. And if you remember, we had a couple of Ethernets here, virtual Ethernets. So we'll call this virtual Ethernet 1 and virtual Ethernet 2. And I've got my kubelet down here. The kubelet really doesn't come into play here anymore, but I'll leave it here. So the kubelet. And I've got Kubernetes here. The rest of the Kubernetes infrastructure. And the kubelet is talking to that. And I have the CNI plugin. Again, that's not really going to come into play anymore here. CNI is sending traffic that way. The kubelet's talking back and forth to Kubernetes, and the kubelet is talking to the CNI plugin. Now there's a couple of new things that we're going to introduce to the puzzle. And these are the things, these are going to be different depending on what the networking plugin is. So Calico's mechanics here are going to be different than some of the other networking plugins that might exist out there, like Flannel or Weave or any of the others that exist. We're going to be talking about Calico here as an example. So Calico has a pod that it runs in the host namespace, which is called the Calico node. And Calico node has two components in it. Calico node has a Felix and it has another pod. We'll talk about another workload. We'll talk about that in a minute. Right now it's got Felix. So Felix is talking to the Calico key value store. Now that might be an actual standalone store. More likely today, we see this as most people are deploying this where the Calico key value store is actually using the Kubernetes API server as the store. So in reality, Felix is talking to the Kubernetes API server, and the Calico, the data it's going for, the Calico key value pairs are stored in that Kubernetes API server. So it might be talking to something that's standalone, like etcd, that's a standalone instance, or it's talking to the Kubernetes API server. But it's basically, either way, it's getting some data. Let's talk about what's stored here really quickly. In these key value stores, there's three things that are stored here. One is configuration. And this is things like IP address ranges to use. We call those pools. NAT settings, BGP, which we'll talk about in a little bit, settings, etc. So configuration is one thing that's stored. The other is inventory. And inventory is the pods, their IP addresses, locations, and labels. Metadata that Kubernetes is attached to those pods. And again, we'll talk about those when we get to network policy. And the last thing is intent. And I'm going to leave intent a black box for right now, and I wrote that too high, so I'll just put it right here. Intent. But we'll fill out the intent box later. So what Felix is going to be interested in is this right now, is this inventory piece. So Felix watches the key value store for updates to, again, just like the kubelet is only paying attention to things that Kubernetes wants it to do on its given host. The same things, Felix is only responsible for networking on that particular host or that particular server. So in this case, Felix is watching for updates. Felix on host 1 is watching for updates about inventory on host 1. Felix on host 2 is looking for updates to inventory on host 2, etc., etc. So in this case, this Felix is going to find out that we have networked two pods on that host, on its host, A1 and A2. So what Felix is going to do is going to make sure, first of all, go to confirm those, that, and the reason we know that's stored here is because the CNI plugin told Kubernetes that the pod that it was asked to network was given an IP address of A1, virtual Ethernet 1, etc. So Felix gets that information from Kubernetes or from the key value store and acts on that. The CNI plugin could have told Felix that directly. We're on the same host. But that sort of breaks the Kubernetes model of the source of truth is Kubernetes API server and anything that hangs off of that, let's say Calico's dedicated key value store. So Felix will now find out about this. So all Felix is going to do is update this routing table. So it's going to say IP address A1, next hop is virtual Ethernet 1. It's going to say IP address A2, next hop is virtual Ethernet 2. Now, similarly, we might call this Eth0. The host has a network connection as well. So what we've done here is we've basically put an IP routing table entry in this host that basically says whenever traffic gets delivered to this host, whenever this host receives traffic with a destination of A1, it knows to send that traffic down virtual Ethernet 1. And this is a key difference to Calico versus some of the other overlay or virtual networking environments. A lot of the other virtual networking environments have mixed mode behaviors where, for example, they might use Ethernet switching and stick those virtual Ethernets in overlay networks like VXLAN or something along those lines and build lots of little networks and use L2 switching concepts to move traffic between pods. And the behavior of that might change if it's on the same host or on different hosts, i.e. it might have a standard bridge here versus a routing table, and A1 and A2 ARP for each other. But if A1 is trying to talk to something on another host, it then goes over this VIF encapsulation path. But the concept of a lot of these overlays is Ethernet switching. And Ethernet switching has problems at scale. One of the things that you get in a Kubernetes environment, a very dynamic environment, and a potentially very high scale environment, that is not particularly friendly for an Ethernet switched. Ethernet switching doesn't deal with either of those cases all that well, and you put the two together, interesting things can happen. So what we did with Calico said, we're going to build this the way you build the public internet. We know that works at scale. We know that works at a high level of churn, which means we're going to route traffic instead. We're going to make forwarding decisions based on the IP addresses, not the Ethernet MAC addresses. So that's what we're doing here. So now, whenever a packet comes in to this host, it could be coming in from F0, it could be coming in from VE1 or VE2. Wherever a packet comes in destined for address A1, this host will route it and send that packet down A1, down VE1 to A1. If A1 tries to talk to A2, the traffic would be delivered from pod A1 to the underlying host over VE1. It gets looked in the routing table and says, oh, well, A2 is on VE2, and we'll send the traffic up the virtual Ethernet to A2. A1 and A2 can't talk to anything other than their underlying host, because that underlying host is their next hop router. Similarly, traffic comes into F0, addressed to A1. Again, the routing table will go look it up and say, oh, send that to VE1, and that gets delivered to the A1 pod. And similarly, if A1 tries to talk out, it will follow the routing table, usually a default that says send it out F0.